Today we are going to discuss refraction in thick lens. In fact, in your previous classes you have studied refraction in a thin lens and you have already seen the thin lens formula. But here our aim is to discuss to obtain the thick lens formula. In fact, in this problem you will also see that how we can calculate the cardinal points of a thick lens. So actually the today's lecture has two basic problems or two basic aims. First of all, we will find the cardinal points of a thick lens, and after that you will get the expression for the thick lens formula, that is for the focal length of the thick lens. So for this, let us see this figure. I have shown a thick lens in this figure. You can see that this lens has actually two curved surfaces. This surface which is marked by 1, this is its first surface, and marked by 2, this is actually its second surface. And O1 and O2 are actually the poles of these two surfaces. So the distance between O1 and O2, this is O1 and O2, this is actually known as the thickness of this lens. And this thickness has an appreciable value which cannot be neglected. So you can see I have shown in this figure that thickness of this thick lens is T. First of all, we will see how the image of an object will be formed by refraction in this thick lens. For this, let us consider that this P is a point source situated on the optic axis of this thick lens. So how the image will be formed by this thick lens of this object P, we will see it. As you know, since this is just a combination of two curved surfaces, this thick lens is just a combination of two curved surfaces. So we will actually apply the concept of image formation in case of the combination of curved surfaces. And you know, in case of two curved surfaces, the image formed by the first surface actually acts as a virtual object for the second surface, and then the final image is formed. So you can see in this figure, I have shown here that a light beam, this PA, is incident on the first surface of the thick lens and gets refracted. And if you want to know the position of the image formed by refraction at the first surface, definitely you have to assume that there is no second surface. This is just a technique. If you consider that there is no second surface, then the refracted ray from A will meet to the optic axis at this point Q1. So actually this Q1 is the image of the point source P formed due to the refraction at the first surface. But actually the second surface is present, so in fact now this Q1, which is in fact the image of the object P, which is formed by refraction at the first curved surface, this image Q1 now acts as a virtual object for the second surface, and finally the image is formed at Q. So this Q is actually a real image in accordance with this figure. And now you can see when we will measure the object distance from the first surface, that distance will be what? That distance will be simply this O1P. Distance will be measured from the pole of the first surface. So this O1P is the object distance, which I have marked by U. And since Q1 is the image for the first surface, so image distance for first surface will be actually equal to O1Q1, and that has been marked by V1. So V1 is the image distance for the first surface. Now since Q1 acts as an object for the refraction at second surface, and Q1 acts as an object for the refraction at second surface, and so its distance from the second surface, that is object distance for the second surface, will be O2 q1, and this O2 q1 you can see in this figure. This will be actually equal to the object distance for refraction at the second surface, and for this object q1, q is the image, so O2 q is the image distance for the second surface. You can see, actually I have also assumed that the refractive index of the material of this thick lens is n. You can see here, and this thick lens has been placed in air, so the refractive index of the surrounding medium is simply equal to 1, because you know we simply take refractive index of air equal to 1. Now in fact our aim is first of all to find the image distance, or how the image distance is related with the object distance. First of all we will find that basic equation, and that will be obtained by using the formula which is actually known as Gaussian formula for refraction at a curved surface. So you can see here, this is your Gaussian formula for refraction at a curved surface. This is given as n2 over b minus n1 over u equal to n2 minus n1 over r. Actually here n2 is the refractive index of the second medium, v is image distance, n1 is refractive index of the first medium, and u is the object distance, and r, this is actually the radius of curvature of the surface where refraction takes place. Now we will apply this Gaussian formula for refraction at these two surfaces separately. So you can see, when you see the figure, this is your first surface which I have marked by this one. This is your first surface, and this first surface for this first surface P is the object, and object distance is u, and we can consider that the radius of curvature for this first surface is r1, and this q1 you know is the image distance. Q1 is the image, and its distance will be O1 q1 from the first surface. And in this case you can see the medium, in fact where your object is situated, that is called a first medium. So in this case n1 will be equal to 1 and n2 will be equal to n. You can see here. So when you will apply this formula for the first surface, then you can see I have written here that n1 is equal to 1 and n2 is equal to n. R is r1 and u is simply u, but v is here equal to v1, not v, but this is v1. You can see this figure, I have marked it by this v1. v1 is the image distance for the first surface. So now we will use this formula in this equation. Say this equation is a, not 1. This is a general formula. So when we will use these values in this Gaussian formula which has been defined in equation A, then for first surface you can see our result will be n1 over v1 minus 1 over u equal to n minus 1 over r1. You can see all these values here. Now we will apply the same Gaussian formula for the refraction at the second surface, and you have seen I am just making the second surface here. You can see this figure. This is your q1, that is which is image for the first surface but object for the second surface, and this is q, and this point is O2, and we have assumed that this O2 q2 is v, and O2 q1 will be actually the image distance. The O2 q1 will be actually the object distance for the second surface. So for the second surface you can see, first of all see, For the second surface, actually a ray is going like this. So n1 in this case will be equal to n, and n2 will be equal to 1. So in this case, n1 is equal to n and n2 is equal to 1. And let us consider that radius of curvature of this second surface is r2. We consider it. And you can see this figure, what will be actually u. Actually in this case you can see u will be equal to what? According to the figure, u will be equal to O2q1. O2q1. And see the first figure. When you want to find the value of O2q1, you can simply subtract this O1O2 from O1q1. When you will subtract O1O2 from O1q1, then you will get O2q1. So you can write here that this u is equal to O2q1, and that O2q1 is equal to O1q1 minus O1O2. You have seen this in the figure. But what is this O1q1? You have seen that this O1q1 is equal to V1. See here. This is V1. And O1O2 is what? This is actually the thickness of our thick lens, and we have assumed it T. So in this case, u is equal to V1 minus T. And what is this V? V I have considered this is O2q2, and let us say this is equal to simply V. So now we will apply the Gaussian formula which we have defined in this equation A for the refraction at second surface. So you can see this formula and put these values. So for the second surface, you can see for the second surface, what will be your result? N2 over V. And here N2 is equal to what? N2 is 1. N2 is 1. And over V. And when you say V, let us consider that this V is equal to what? V is equal to V. We have considered that V is equal to V. And minus N1. N1 is here N. And over u, and you have seen that u is actually equal to, in this case, what? U is equal to, in fact, we have considered that u is equal to, see here, u is equal to V1 minus T. This is V1 minus T. So this will be V1 minus T. V1 minus T. And this equal to N2 minus N1. N2 is 1 and N1 is N. And R we have assumed this is R2. So 1 over V minus N over V1 minus T is equal to 1 minus N over R2. So this is the Gaussian formula for the refraction at the second surface. Now let us make a simple substitution here to simplify the result. So you can say, on putting y1 equal to V1 over N and T prime equal to T over N. We consider it. Then equation 1 and 2 become. After this substitution, what will be our equation 1 and what will be our equation number 2? You can see it easily. See this equation 1. Equation 1 is N over V1. and we have considered that v1 over n is equal to y1. So n over v1, that will be 1 by y1. So this is 1 over y1 and minus 1 over u, and that is equal to what? N minus 1 over r. Not r, but r1. But you know, n minus 1 over r1, this is what? We denote it by the symbol p1, and actually this p1 is the refracting power of the first surface. And say this is your equation 3. So here p1, which I have written instead of n minus 1 over r1, this is what? This is refracting power of first surface. Refracting power of first surface. See here. Similarly, we will now write this equation number 2 in terms of these substitutions. So you can see 1 over v is at is, and minus, you can write this equation in this manner: 1 over v1 over n minus t over n. You can write this, and this equal to 1 minus n over r2. And now see, this will be 1 over v minus 1 over. But see here, v1 over n, that will be equal to 1 over y1. So you can write it 1 over y1, and minus t by n. You can see we have assumed that this t by n is equal to t prime. So this is t prime, and this is equal to what? This is equal to p2. Let us say. Actually, you can see this p2 is equal to 1 minus n over r2, and this is actually the refracting power of the second surface. This is a refracting power of the second surface. Refracting power of the second surface. Now finally our aim is to establish a relation between v and u in terms of p1, p2 and this t or t prime, you can say. And for that you can see both of these equations contains this y1. Y1 is contained in both of these equations. So first of all, we will eliminate this y1. And for eliminating this y1, what you will do? You can find the value of y1 from equation 3 and then substitute that value of y1 in this equation 4. Then you will make the equation free from y1. So, and after that we will get a relation between v and u. So, from equation 3, you can see this equation 3 says this is 1 over y1 equal to what? This will be p1 plus 1 over u, and that will be equal to u p1 plus 1 over u. And so you can see this y1 will be equal to what? You can see this y1 will be equal to, see here, this will be u over up1 plus 1. So this will be equal to u over up1 plus 1. Say this is your equation 3a. This is equation 3a. Let us say. Now we will substitute this value of y1 in this equation number 4. In this equation 4. So you can see from equation 4, from equation 4. What will be this 1 over v? See this equation 1 over v. Take this second term in RHS, that will be in fact P2 plus 1 over y1 minus t prime. And let us take the LCM. This will be simply y1 minus t prime. This will be P2 times y1 minus t prime plus 1. And so you can see what will be the value of v. V will be y1 minus t prime over P2 times y1 minus t prime plus 1. Now substitute this value of y1 from equation 3a in this equation. So putting for y1 from equation 3a, what will be your result? You can see this v will be y1 minus t prime. Y1 is what? This is u over up1 plus 1 minus t prime and over p2 times y1 minus t prime. But y1 is what? This is u over up1 plus 1 minus t prime plus 1. Now you can simplify it by taking LCM. So you can see this will be u minus t prime times up1 plus 1. I think you are getting the things. This is a simple calculation, and over up1 plus 1 and whole divided by, you can see this is p2 times u minus t prime times up1 plus 1 and divided by up1 plus 1 and plus 1. Actually now there will be a lot of algebra, but finally you can see this up1 plus 1 will cancel out, and when you will do those algebra, then you will get a simple result. Actually I am writing that result directly in terms of some extra notations. So we get, you can say, but this is just a homework for you. You can do the algebra, and after doing the algebra you can see that expression for v may be written as what? Remember it. V is equal to cu plus d over au plus b. Write this expression in this manner. But how these u, c, d, a and b are defined, you can see here. Actually when you will simplify the algebra, then you will get this result. So where you can say, where a is equal to p1 plus p2 minus p1 p2 t prime, and b is equal to 1 minus p2 t prime, and c is equal to 1 minus p1 t prime, and this d is equal to minus t prime. And from these values of a, b, c, d, you can see a very important relation which will be used further to calculate different useful quantities, but you can check it. So it is found that you can check it. This BC minus AD will be equal to 1. This is just a simple result, and you can check it because we know the values of A, B, C, D here, and when you will put the value of B, C, A and D in this equation, you can easily see that this BC minus AD is equal to 1. So I am not doing that algebra. You can do it. Actually, this equation 5, which you can see here, relates the conjugate distances u and v. You can see this is just a relation between u and v, and these distances have been measured from the poles O1 and O2 as you have seen in the figure. So this is the basic equation, that is equation 5 and 6, and after using these two results, you will see in the forthcoming lectures how we can calculate the principal foci, the principal point, the nodal points and focal lengths, etc. Actually, this is a long calculation, so for your convenience, I will complete this lecture in 3 lectures, not in 1 lecture. So this is the first part of those 3 lectures, and in second and third part we will complete this concept.